Okay, so we go to question 5. Question 5 probability. A bag contains 20 chocolates, 15 toffees, and 12 peppermints. If 3 sweets are chosen at random, what is the probability that they are A, or different? The probability that they are all different. First thing to be understood is how many do we have? We have 20 chocolates. We have 15 toffees. We have 12 peppermints. So from there, how many altogether do we have in the bag? We have 20 plus 15, 35 plus 4, 47 altogether. What is the probability that what you're picking? Okay. If 3 sweets are chosen at random, what is the probability that they are all different? Same story.
Sir, I don't know if I'm the only one, but I can't see anything.
Sorry, you're the only one.
Okay, so try rejoining. Okay, so not to have all different when you pick, it's either you have one chocolate, one toffee,
I can't see anything.
one
It has
peppermint.
strips.
Or you start with a toffee, peppermint, chocolate. Chocolate, peppermint, toffee. But there should be 3 and different. So no repetition. So you can't have 2 toffees. It's only one in all combination. So what you do is you pick the probability of the orders now, having the chocolate, toffee, peppermint. Or having the chocolate, peppermint, toffee. Or having peppermint, toffee, chocolate. Or having peppermint, chocolate, toffee. Or having toffee, peppermint, chocolate. Or toffee, chocolate, peppermint. It's just about how you're getting them. So you're saying I can have 3 all different, but picked in different orders. Then, if you start by picking chocolate, the time you're picking, you find there are 47 in the box, but there are only 20 chocolate. So you have 20 out of 47. Because you have picked one, it's no longer 47, it has now become 46. You go back, you want to pick a toffee, but you have 46 altogether in the box. So you pick from 15 toffees out of 46. When you pick, it's now 45 remaining. Which are picking peppermint, there's still 12 out of 45. Plus, you start with chocolate, 20 out of 47. Then peppermint, 12 out of 46. Then toffees, 15 out of 46. Next, peppermint, 12, when there's 247. Toffee, 15, when there are 46.
Not 45 there. The second one.
45. the last one. Then 20 when they're 45. The combination with the down numbers won't change. Then peppermint 12 when there's 247. Chocolate 20 when they're 46. Toffees 15 when they're 45. Last toffees 15 when they're 47. 12 when they're 46. And 20 when they're 45. Plus toffees 15 when they're 47. 20 when they're 46. And 12 when they're 45. So what we get up here. So you can see that these are same numbers. So just count how many are they? 1, 2, 3, 4, 5, 6. So 6 multiplied by one of them. The same as adding them 6 times. 15 out of 46, 12 out of 45. So you can see 15 goes here once, 15 goes here 3 times. 3 here once, 3 here 4. Then now we multiply. So 20 times 4, you get 80 over 47 times 46. You get 2162. Then I multiply by 6 outside. Then I multiply 80 by 6. You get 480. 480 over 2162. Then maybe you can simplify. 480 divided by 2. You get 240. And then down 2162 divided by 2. You get 181. So that's the setup there. B, if they are all chocolates, the probability that they are all chocolates. This is an easy one. So you get the first one, chocolate, second one, chocolate, third one, chocolate. There are no options, you just need chocolate. So if you pick first chocolate, second chocolate, third chocolate. You switch the C's in any way, it's 2 chocolate, chocolate, chocolate. So when you pick a chocolate first, you find that you have 20 chocolates in the box out of 7 sweets. You go back, you find you have 19 chocolates out of 46. You go back, you find there are 18 chocolates out of 45. Let's start calculating now. What figure do you get? So 20 by 19 by 18. You get 6840 over 7 by 46 by 45. You get 97 to 90. Then divide. So you have 6840 divided by 97290. So we get 76 over 1081. Then C, they are all the same. The probability that they are all the same. So all the same would imply you have chocolate, 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 or you have toffee, 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 or you have peppermint, peppermint, peppermint. So chocolate, 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 you have already found it here. 76 out of 1081. Then toffee, 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 15, 47, 14, 46, 18, 45. Then peppermint, 12, 47, 11, 46, 10, 45. Calculate to get the figure, yeah? And then D, all toffees or peppermint. So bet that they are all toffees or peppermint. You just pick this number plus this one. Where we have all toffees or peppermint. Like that. So I've avoided a tree just by understanding what goes around when I pick. The tree may look nice, but it can consume a lot of your time. So if you're able to read and understand, then survive without the tree. Okay, next, question 6.
Now, can I see your previous board?
Okay, so question 6. This is some bonus questions. I'll go to 7. You can go to 7. Is it okay? Wonderful. So this one's your task.
The previous words I asked.
I think you tell me that we're done. So question 7, bag A contains 3 white counters. So we have 2 bags. This is bag A. And then you have another bag here, which is bag B. So bag A contains 3, 1, 2, 3 counters and 2 black. 1, 2. Bag B contains 2 white, 1, 2, and 3 black. 1, 2, 3. Then 1 counter is removed from bag A and placed in bag B. So 1 counter is removed from here, okay, taken to B. So I'm taking a counter here, we're taking it to B. Okay, we don't know whether it's white or it's black. What's the probability that a counter removed from bag B will be white? So you take a counter from A, you take it to B. What's the probability that if you go to get a counter in B, the counter you get will be white? So the story is here. I have a tree. This is bag. A minute first. So if I have a tree, this is bag A. I'm in bag A. I'm in bag A. Then from bag A, I go to bag B. I go to bag B. This is bag B. This is bag A. And bag B. So I start with bag A. I pick white. So bag A white and bag A black. Variable different colors. Bag A white, bag A black, bag A white, bag B white, black. So suppose that you get a white ball from bag A. The probability of you getting a white ball from bag A, since you have 5 balls altogether, and the 3 are white, it is 3 out of 5. And the black is 2 out of 5. If you took white in bag B, then you are saying bag B, if I took white in B, then B now has 1, 2, 3, 4, 5, 6. Well, these 3 are black. Because I took white, so I now have 3 whites in B and 3 blacks. So if I pick from B, the probability is going to be 3/6 of picking white. If I pick black, it will still be 3 over, if I pick black, it should be 3 out of 6. Why 3 for black? Because we initially have 3 blacks. We go to the other one. If I pick black, okay, if I pick black to take in bag B, then bag B will have 1, 2 white, and the blacks will increase. So now I'll have 2. If I'm picking white, I'll have 2/6. Then black, it will be 4/6. Then what's the probability that I pick white in bag B, given that I picked white? Now what's the probability that I pick white in bag B? It's going to be the probability of picking white in B, given that I picked white in A, or picking white in B, given that I picked black in A. So white in B, given white in A, it will be white in B in that line. So I'll have 3/5 multiplied by 3/6. Or pick white if you picked black. So 2/5 if we picked from 2/6. That's 9/30 plus 4/30, which is 13/30.
I repeat the way you're getting the probabilities, they're not clear.
On the table,
Me too. I'm not very clear on the bags. Like when you
Explain.
transfer this,
From the bag,
Right.
yes, and transferring I've understood. But here when computing, if finding the probability, I don't know if it's white in a black bag, in bag B.
That's the bag.
If you have, so for the first three, there's no problem. Bag A, bag B. I mean, bag A, there's no problem there. Okay? Because there's no
I
problem.
have a problem. I have a problem. I didn't understand on how you were transferring them from one bag to the other.
Before you
How you
transfer,
were when you were transferring.
before you transfer in A, you are picking to transfer. So you say the probability of you picking white out of 5, since I have 3 whites, that is in A. In A, the probability of having white in A is 3 out of 5. In total, we have 5, and there are only 3 whites. So if you want to pick, there are only 3 possibilities that you can pick. I mean, there are only 3 chances of you picking a white out of 5. Because the other 2 are not white. If you're picking black, you have 2 out of 5 possibility of getting black. So this is in A. If you pick white out of 5, there are only 3 that are white. So you only have 3 out of 5 chance of having white from A. That white, you take it in B. This white, you are taking it in B. Whatever you have picked, whatever color you have picked, you're taking it in B. Suppose that the boy you have taken in B is white. Since B has 2, if you take white, you no longer have 2. You have taken 1 more white. So they will become 3. So that altogether, you have 6 in B. Since we had 5, now we have 6 because we have brought in 1 more. First thing, the number in B has increased to 6. That's why we have 6. If you pick white after bringing white, you have 3 out of 6 chances of picking white because you now have 3 whites. That is this probability here. Then, if you have taken white in B and you want to pick black, since you have 3 blacks, even if you brought white, since you have 3 black, you have 3 out of 6 chance of having black. That's why we have this probability here. The total number of blacks has not been disturbed because you have brought in white. You go back to A. If from A you picked black, in B, where we had 3 blacks, they will increase because you're bringing black, they will go to 4. The whites are fixed because you have brought in black. If you pick white after bringing black, you still have 2. So it will be 2 out of, because you have increased the number 5 by 1, it has become 6. So you have 2 out of 6. So that if you pick black, they are no longer 3, they have become 4. So you have 4 out of 6. What is the probability that you are going to pick white in B? There are 2 chances. That it will be white even after bringing white, or it will be white even after bringing black. So you multiply the probabilities. Black, white, second, or white, white. That's why we have 3 over 5 multiplied by 3 over 6. I said on the tree, you multiply.
So, sir, when multiplying, and don't consider those that branch which goes down there, like that one which is having 3/6, and that one which is having 4/6.
You only want white, so you can't go for black.
So if we picked black, we could have gone for that one which is down.
Yeah, if they said black, you'd have said black. Okay, so if you look at question 9, it's entirely based on question 1 and 2. That's not a big challenge there. And question 9 is the last question that covers the exam. And then you have question 8 remaining. So again, from the understanding of question 7, then you are able to practice again on 8. So I've only left 2 for you to practice, question 6 and 8. If you fail to practice, you find that there are solutions that we are giving you. So it shouldn't be a big deal. So that you rest since you had 2 assessments today. You can rest as we end probably. Linda,
Yes, sir. We're asking for the rating.
I didn't get you.
Yes, sir.
You are asking for?
Yes, I'm saying that I'm asking. We are for the recording. For the
Okay, I was saying.
recording class, I joined late.
Okay, I was saying.
YouTube.
All right.
Yeah, I was saying. Okay, so we end probate here. Because that's where it ends.